Hey, geometry, make sure you open up the vocabulary definitions file first. Get used to some of the terms. Today we're going to be using terms like how to name a circle, the radius, diameter, chord, circumference, things like that. So run through there and make sure you understand most of those terms. Some of this will be a little bit of a review for you. And if it's new for you, just make sure you understand what we're talking about before you move on to the next portion. So for starters, let's talk about how to name a circle. This is my circle. It's not perfect, but it is mine. So how am I going to name a circle? All circles must give you a midpoint. And we call that, let's say we call that midpoint A. So my circle will be called circle A. That's how we name it. All right. A radius is from the midpoint to an outside edge to any outside edge because it's a circle. The midpoint is equal distance from all the outside edges. So let's call that point B. My radius would be AB, line segment AB. Right? A diameter goes from an outside edge through the midpoint all the way to another outside edge. So if I did that, let's call this point C, this point D. From one outside edge through the midpoint all the way to another outside edge is my diameter. So I would call this one, CD or DC. Okay. Notice I don't call it CA. Notice I don't call it AD. I call it whatever the outside edge point is all the way to the other outside edge point. Clear? A couple other things. Circumference. You need to know the two measurements of circumference. If we have a diameter, we're going to use pi times the diameter. If we have the radius, we'll use 2 pi times the radius. Now, why 2 in this one? Well, because our diameter is 2 radii. Okay, so a radius is from the center point to an outside edge. The diameter is 2 of those. From the center point to 2 different outside edges is our diameter, right? So pi times our diameter is the same as pi times 2 of our radiuses, radii, okay? Also, chord, the word chord is similar to a diameter. The word chord is similar to a diameter. It's just from one outside edge to another outside edge, but it doesn't go through the center point. So diameter is kind of a chord, but it's a special one. A chord is just from any outside edge to another outside edge, but it does not pass through the center point. Okay, that's the big difference. So chord measurements change even within one circle. I can have the longest a chord could possibly be is the diameter, and it can constantly get shorter and shorter and shorter. So I can have another chord up here, just a little tiny piece of that circle, right? From one outside edge to another close outside edge. So my chord could be very small, or it could be as big as the diameter. All right. I hope you understand those terms. I'm going to hit pause real quick and open up the notes section. Please keep track. I'd rather you listen to my voice while we go over the notes than actually watch. Let's see. And I'm going to hit pause. All right, for number 1, we're looking at this type of a circle right here. We're going to name that one circle R because of the midpoint is R. And number 2, it says name the radii. That's how you say that, radii, radii of the circle. Okay, all of the radii are going to be from the midpoint to the 4 outside edges. So we have line segment RA, RB, RX, and RY. All of these will be line segments, so make sure you have the line over the letter pair. Okay. Name chords of the circle. Remember, chords go from one outside edge to another outside edge, but do not cross through the midpoint. So we have a chord here from A to X, so we'd call that line segment AX. And then we have another chord down here from Y to B or B to Y, either one. So we'd call that line segment BY or YB. Okay. To name the diameters of the circle, remember diameters go from an outside edge through the midpoint to another outside edge, so we'd call that line segment AB. And the other diameter would be line segment X, Y. Notice that we don't call it R or anything to do with R because it goes from one outside edge to another outside edge. We need to talk about those two endpoints. All right. Number 5 says find AR if AB is 18 millimeters. So if we look at AB, the whole length from one outside edge to the other outside edge is 18 millimeters. So how long is A to the midpoint? Well, we already talked about the diameter being twice the length of the radius. So we're going to take that 18 millimeters and divide it by 2 and call that 9 millimeters. So AR is equal to 9 millimeters. Number 6 says find AR and AB if RY is 10 inches. If RY is 10 inches. This is another radius right here. So if the radius is 10 inches, what is AR? Another radius. And what is AB? A diameter. Okay. Remember, a radius, all the radii must be the same, and the diameter must be, each diameter must be 2 times a radius. So if RY is 10 inches, then AR must also be 10 inches. And then AB will be twice that, which is 20 inches. Number 7 says if line segment AB is congruent to line segment XY, if line segment AB is congruent, or is line segment AB congruent to line segment XY? And the answer is yes, because they're both diameters. They both go from an outside edge through the midpoint to another outside edge. That is the longest chord you can have, right? So our diameters must be equal to each other. So is line segment AB congruent to line segment XY? Yes. They are both diameters. I'm going to hit pause real quick and set up for the next one. All right, for numbers 8 and 9 here, we have a diagram like this. We have 2 circles. We have one small circle with the center point F and one larger circle with the center point G. So we have circle F and we have circle G. All right. Now it tells us that the diameter of F from A all the way to G, do you see the diameter of F is going to be equal to 5 units. So from A all the way to G, from A all the way to G is 5 units. Now it says the bigger circle has a diameter of 6 units. So from B all the way to C is 6 units. Okay? So the diameter of the big circle is 6 units. The diameter of the small circle is 5 units. That's what we know so far. Now I want to know what is the length of BF. BF is this tiny little section right here. Okay, so we're going to be dealing with the circle's radius or radii, each one of them. So first, we need to identify how long is G to B. How long is G to B? Well, if C to B is 6 units, then G to B is going to be 3 units. From G to B. All right, then we need to identify how long is it going to be from F to G. Well, if A to G is 5 units, then F to G is 2.5 units. Okay? So we have 3 units and we have a measurement that's 2.5 units. So what is the leftover amount of units? It is 0.5 units from B to F. Now, once we know that, we can tell you the distance from A to B. A to B, right? If F to G is 2.5 units because A to G is 5, then F to A must also be 2.5 units from A to F. And if we know that B to F is 0.5 units, then that's going to tell us the remaining number of units to go from A to B. It must add up to 2.5 units. We subtract that 0.5, and we know that A to B is going to be 2 units. Now, I hope that was clear. If you have any questions about that, make sure you put it in the comments section of this posting, which will be March 30th. Okay, let's look at 10 through 12 real quick. 10 through 12, you're going to need to know how to find the circumference. We can do pi times d or pi times 2r. So we are given the diameter is equal to 1/3 of a meter. Find the circumference to the nearest hundredth. Okay. If the diameter is equal to 1/3 of a meter, we're just going to plug it in here. So 1/3 times pi, and that will end up with 1.05 meters. 1.05 meters. All right. Number 11 says if the radius is 8 centimeters, how long is the entire circumference? We're going to plug in 8 for r over here for number 11. So 8 times pi times 2, and we're going to round to the nearest hundredth. 8 times pi times 2. Remember, it's all multiplication. So 2 times pi times 8 is going to give us 50.27 centimeters. Number 12 is asking us, what if it's 3 times the square root of 2 for the radius? Just plug that right in. So we'd have 2 times pi times 3 times the square root of 2. And that would give us about 26.66 feet. All right. For number 13 and 14, you need to know how to find the diameter after given the circumference and how to find the radius if given the circumference. So if the circumference is equal to pi times the diameter, then the diameter is equal to circumference divided by pi. And if circumference is equal to 2 times pi times r, then the radius is equal to the circumference divided by 2 times pi. Okay, we knew that from literal equations in algebra. So if I have a circumference of 227.6 yards, I'm going to plug it in here, divided by pi to find the diameter. And I'm going to plug it in here, divided by 2 pi to find the radius. And then on number 14, it says the circumference is 35.7 inches. I'm going to plug it in here and divide it by pi to find my diameter. And I'm going to plug it in here, divided by 2 pi to find the radius. All right? And then 15 and 16. All right, number 15 has this shape right here. It's a triangle inscribed inside of a circle. It gives us a 90-degree sign. It gives us our long leg, which is 12 centimeters, and our short leg, which is 5 centimeters. And then it has this line right here. We don't know quite what to call it, but we do see that it is the hypotenuse of this triangle, but it also goes from the outside edge through the midpoint all the way to the other outside edge. So what can we call that? That's also a diameter, okay? So if it wants to know the circumference of the circle, and it says to leave the answer in terms of pi, so that means leave pi as the symbol in your answer, right? So we're looking for the diameter, and we know that diameter times pi is our circumference, okay? Or pi times the diameter is the circumference, whichever way you want to say it. So first we need to find out what this length is of our diameter or our hypotenuse. So we do 5 squared plus 12 squared, 25 plus 144, and we get 169. That's a perfect square. So we do the square root of that to find this length from our outside edge to our other outside edge, and we find that that is going to be 13 centimeters. Well, if we know that the circumference is equal to the diameter times pi, and we know our diameter, and we're supposed to leave pi in the number, then we can just say that the circumference is equal to 13 pi, or 13 times pi, okay? So that's problem number 15. Problem number 16, we have this cool shape right here, which is maybe a square. Is it a square? I don't know. You tell me. Is it a square? Yes, it's a square inscribed inside of a circle. And then we have a diagonal here. That diagonal is going to be our diameter again. Okay, we're looking for our diameter again because it goes from an outside point through the center to another outside point, outside edge. Then it gives us all these chords telling us they're all the same length. So all of these measures are the same length, which helps us know that this is a square, not a rhombus, because there's no change in it's all inscribed in a circle, so it must be a perfect square if all these chords are the same. So that tells us that these angles right here are 45 degrees and that these are 90 degrees. What do we know about 45, 45, 90 triangles? Is that the hypotenuse of that is, if we have 45, 45, 90 triangle, we know that the outside edge is outside side is x, and the hypotenuse is x times the square root of 2. So we know that this diameter is 3 because that's what the outside edge times the square root of 2. So we're going to plug that into our formula of circumference is equal to diameter times pi. We know the diameter is 3 times the square root of 2, so we're going to say the circumference is equal to 3 times the square root of 2 times pi. 3 times the square root of 2 times pi. I hope that helps. If you have any questions, please make sure you ask them in the comment section on March 30th video, on the March 30th Google Classroom posting. All right. Please, I don't think you can add any comments or questions in the comment section of the YouTube video. All questions must go through Google Classroom. Also, please don't direct message or direct email. I don't see those. Okay? Have a great and wonderful day, and enjoy the practice problems.